In this lecture, we're going to learn about the std stack container adapter. In the last lecture, we saw that this is really not a container class. It is an adapter which is going to change the interface of some sequence containers to give us the stack interface. And a stack is something that works in this way. The first thing to get in is going to be the last thing to get out. So if we add in a 1 here and add a 2 and add a 3 and add a 4 again, when we get to want to remove elements, the elements that will be removed are those at the top or those that were added last. So if we remove, we're going to remove a 4 and remove 3 and remove 2. This is the design principle of stack containers. Now, we can use some built-in sequence containers to set up the stack interface, and all we need is something that supports the back method, a pushback method, and a popback method, and we have a few candidates that we can use in our C++ programs. Here are a few facts you need to know about the stack. It is not a container per se. It is an interface built on top of some sequence containers that we have learned about before, and the candidates are std, vector, list, and deck. The first thing to get in is going to be the last thing to get out. And these are the methods we need for this to work. You already know these things really. The default underlying container for stack container adapters is going to be deck, but we have the flexibility to change this on the fly. You're going to see how we can do that. And we access elements only from the top using the top method. This is the only way to get things out of the stack. And the last thing to get in is going to be what is going to be picked up by the top method here. This is how stack container adapters work. We can call the top method repeatedly until our stack becomes empty. And we have a bunch of methods we can use to manipulate a stack. If you want, you can come to the documentation and see all about this container adapter. We have a bunch of capacity methods. We can access elements through the top method. We can add elements through the push method or in place method. And we can pop elements to get the top element to get out of the stack or take it out of our stack container. Okay, now we can look at a few examples of how we can create stacks and work with them. You create them very easily using the syntax like this. You're going to say that it is a stack of ints. In this case, you're going to pass the type as a template argument here, and you can print the data, and you're going to see that at this moment, this is going to be empty because we have no elements in, but we can push data. So the moment we push data, the 10 here is going to go to the bottom. We're going to put something on top of this, and then we're going to put 30 on top of this. And if we happen to remove elements from the stack by printing the stack, the last thing to get in is going to be the first to get out. You're going to see that the first thing to get out and be printed is the 30. And this is a good proof that the last thing to get in is going to be the first thing to get out. 20 is going to be second, 10 is going to be third. Here is a good look at our print stack function, which is going to be printing our stack. One thing I want you to notice is that we are passing our stack by value so that we can loop around removing elements as we print them. So what we're going to do, we're going to be looping around, checking and seeing if our stack is not empty. We're going to be grabbing the top element and storing that in a copy item. And then we're going to print that item. Then we're going to pop the top element from the stack. And the next time we get into this loop, we're going to be working on another top element. And this will happen until the stack becomes empty and our loop here is going to end. I want you to take a moment and understand this function because it can throw a lot of people off. Okay, so here are a few things we can do. We can access elements using the top method. The top method is just going to give you a copy. It's not going to take the element out of the stack. This is something you need to keep in mind. And we can modify the top element through our assignment here because the top method is going to return a reference, but this is not very useful. I haven't used this in my many years as a C++ developer, but use this if it makes sense for your use case. Here is a way you can clear the stack. Because we want to modify the original thing, we're going to pass our stack by reference. And we're going to keep looping, popping off elements until the stack becomes empty. This is really easy. Now that we have this function, we can use it. We're going to set up a stack and we're going to put in data. Then we're going to clear the stack and print it again. We're going to see that it is going to become empty. It is also possible to set up stacks of user-defined types. So here we have a stack of books, and we can put the data in. And if we print our stack of books, we're going to see that the data is going to show up. Nothing special here, really. And one last thing I want you to see is that it is possible to specify which underlying sequence container to use as the foundation for your stack object. And we pass this as a second parameter to our statement to create a stack object. We're going to say that it is going to be containing integers, and under the hood, we want to use std vector. You might want to do this if std vector is more performant, for example, for the data you are storing in your containers. You have this flexibility in your C++ program. So we can also specify that we want a list as an underlying sequence container. We can specify dec, but dec is going to be the default. So if you don't want to specify it, you can leave this out, and the compiler is going to fill this in. Now we can put in data using the push method. You already know how this works. But when we get to print these things using our print stack function as it is now, we're going to see that we will see a bunch of compiler errors if we are not careful. The one that uses vector is going to give us a compiler error, and the one that uses list is going to give us a compiler error because the compiler can't figure out the second template parameter that we are using to create our underlying sequence container here. If we go back and look at our print stack function, we're going to see that it takes one template parameter, but we are passing in stacks that take two template parameters, and the second template parameter is throwing off the compiler. This is something you need to be aware of, and you need a way to fix this problem if you come across this in your career as a C++ developer. The way to fix this problem is to tell our print stack function about the underlying sequence container, and we pass that as a second template parameter here, and we can specify the defaults that our stack container supports. So we're going to say dec is our default. Then we're going to pass the second template parameter as a parameter in our function here. This is going to tell the compiler that we might get a different underlying container than dec, and this is going to work. You're going to fix these compiler errors. This is something I want you to know. You see that we are using the same logic for clear stack, and this is going to work really well. Now that you know these things, we're going to go to Visual Studio Code and play with this a little more. Here we are in our working folder. The current project is stack. We're going to grab our template files pretty quick. Let's put them in place. And we are going to open this bad boy in Visual Studio Code by dragging and dropping here. This is going to give us our main CPP file. We're going to clean this up a little bit and include our headers. So let's put them in here. We're going to need the stack header because we are learning about the stack container adapter, and we're going to put in a bunch of underlying sequence containers that we can use to support our stack. We are going to put in a few initial things we need for this to work. We're going to put in our book class, which is going to be used to show that we can store custom items in a stack object. And we're going to go down and set up a bunch of functions we're going to either use to print a stack object and clear a stack. These are going to be templated on the type that we can store in our stack here. So this is going to make this a little bit flexible to work with. And notice that we pass a copy because we want to completely wipe out this copy as we print it. So we're going to be looping around, seeing if a stack is empty. We're going to grab a copy and we're going to grab the top element from the stack. We're going to print that element as you see right here, and then we're going to pop that off the stack and it is going to go away. Next time we hit the next iteration, we're going to grab the next top element, and this is going to keep happening until our stack becomes empty, and we will print it out as you see here. This is one way we can print a stack. Another function you see here is the one to clear the stack. Because we want to modify the original thing, we're going to pass that by reference here. And then we're going to loop around, popping off elements until our stack becomes empty. And that's when our loop here is going to stop. You can use these functions here to play with things. Okay, now that we have this in, we can hop over in the main function and create our very first stack object. We're going to call it numbers1. It is going to be storing integers. And we can print it out, and at this moment you're going to see that it is going to be empty. And after that, we will push in elements. The first thing to go in is this 10. The second thing to go in is 20. The last thing to go in is 30. But if we print our stack, you're going to see that the first thing to get out is the 30 here. And this is why a stack is a first in, last out container. That's what I want you to see here. Let's try and pass this through our container, our compiler, I should say. The build is good, so we can, let's not clear. We're going to bring up a terminal window first, and we're going to clear now and run Rooster. We will see that 30, 20, 10 is our data. The first thing to go in, which is 10, is the last thing to come out. You see that it is printed last. Hopefully you can see this. If we put in more elements, let's try to do that. We're going to put in a 40 and a 50. You're going to see that 50 is going to come out first, and it is going to come in front of the 30 that we had before. So the last thing to go in is the first thing to go out. Let's pass this through our compiler again. The build is going to be good, so we can clear and run Rooster. And we're going to see that 50 is going to come out first. The only way we have to access elements in the stack is by using the top method. So if we use that, it is going to give us the element that is at the top of the stack, and we will be able to access it and print it out. Note that the top function is going to give you a reference, so we can go through this to modify the underlying element, and you can do that if you want. But this is not going to remove the element. This is just going to give you a reference to that element. You can read from it or you can modify it, but this is not going to take it out of your stack. If you want to take that out, you need to call the pop method, which is going to remove that from the stack. And for example, if we print our stack before we pop, let's do that. And we're going to print numbers 1. I think this is going to do. And we pop and print our stack again. You're going to see that the moment we pop off an element, it's going to come out of the stack, and the top element is going to change here. Let's go down and put in a separator to be able to see these things. I think this is going to make things a bit easier. So we can put this in and build and see the output of our program. We're going to use GCC to build. The build is good, so let's clear and run Rooster. We're going to see that the top element is going to be the 50 because that's going to be the first thing to come out. If we try to pop something, we're going to print our data. You're going to see that the 50 is going to be in. And if we pop and print again, you're going to see that the 50 is gone and 40 is the new top element. This is the setup we have with stack container adapters. We can organize the calls to top and the calls to pop into a bunch of calls to set up and print stack function. And this is what we have done in our print stack function template here. We're going to keep looping around calling the top to get the copy of our top element. We're going to print that out, and then we're going to pop that off for the element between that to be the next top element. This is going to keep happening until our stack becomes empty and our loop here is going to stop. As we have said, because the top function returns a reference, it is possible to go through it to modify the top element, and you can do this if you want in your C++ program. In this case, we will print out the stack, and you're going to see that the top element is going to have a value. We're going to change that value and print the stack again, and you're going to see our things changing. Let's try and put in a separator again. We can copy what we have on top here and go down and put in our separator. I think this is going to be much better. We can build our program, but before we do, let's remove these spaces and then build. We can pass this through GCC, our favorite compiler. The build is good, so let's clear and run Rooster. We're going to see that. Now we're going to have our stack of elements, and we're going to modify the top element, and the top element is now 55 because of this assignment here. And this is possible because this top method is going to return a reference. As you can see here in Visual Studio Code, Visual Studio Code is really helpful in giving us this information here. But if you go to the documentation, you're going to see the something. Let's actually go there. This is not that difficult. we can open up our stack container. And if we go to the top method and open this up, we are going to see that it is going to return a reference. And this is really cool. It is possible to clear a stack by using our custom clear stack function. We don't have a built-in way to do this. That's why I showed you this function here. You can go back on top and look at it. It is not difficult to look at by now. We're going to keep looping, popping elements off until our stack becomes empty. And we can look at how we use it here. We're going to print our stack. Then we're going to clear it. And then we're going to print again to show that it has become empty. And we can pass this through our compiler. The build is good, so we can clear and run rooster. We're going to see that we're going to print our stack. It's going to have this data in, and if we clear it, it is going to become empty. Its size is going to become 0, and it's going to really have nothing inside, as you see here. If we print it out, this is what I want you to see here. It is also possible to set up a stack of user-defined type or custom types in your C++ program. For example, here we have a stack of books, and we call it books creatively, and we're going to put in data. After we do this, we can print it out, and we're going to see that our data is going to show up, and this is really cool. Let's pass this through our compiler to see if the build is good. The build is good, as you see here, so let's clear and run rooster. We're going to see our data. We're going to have our stack of books, and we have our books, and the last thing to go in is the first thing to come out. You see that the last thing to go in is containing 2020, and it is the first thing to come out. This is how stacks work. Now, the last thing I want you to see is that we can specify which underlying sequence container to use to support our stack interface. And we can specify this as a second template argument when we create our stack objects. So for example, numbers 2 here is going to be using a vector under the hood. This is the syntax. Numbers 3 is going to be using a list under the hood. Numbers 4 is going to be using a deck under the hood. And this is the default. So if you want, you can take this second template parameter out. You're going to get the same behavior, but I want you to see how to specify your own underlying sequence container. Once we have this set up, we can push in data, and this is going to work really well. Let's pass this through the compiler, and you're going to see that this is going to work. We're going to use GCC to build this, and the build is going to be good. But the moment we try to print these things, we're going to run into problems. Let's try and print numbers 4. We're going to see that this is going to work just fine. We can pass this through our compiler. The build is going to be good, and we're going to clear and run rooster. You're going to see that we're going to print our numbers for collection. It is going to be containing 9 and 10. 10 is going to come out first because it was the last thing to go in. You should really keep this thing straight in your mind. Let's go down and try to print numbers 3 here. We can do that right below here, but the moment we do that, you're going to see that we're going to get a compiler error and something is wrong. Now, the problem is we are passing in a different underlying sequence container, and our print function can't make sense of the crap or the garbage that we are giving it. It is only taking one template parameter, but we are passing in a stack object which has 2 pieces of data in its template parameters. This is the problem here, and we need to help our compiler out. Now you must be asking, why is this working with the deck that we are passing in numbers 4? We were able to print this. Well, the thing is, stddeck is the default container, and the compiler is smart enough to see that it can use that even if we have one template parameter in our functions here. But that's not going to work if you pass in a different underlying container than the default. That's why we have this compiler error here. We can pass this through the compiler to actually see the problem before I show you how to fix it. So let's see the compiler error. We're going to see that we have no matching function called to print stack with a list as a second template parameter here. This is the problem. But we can easily fix this problem by changing the setup of our print stack function to take into account the underlying container. We are going to do that by commenting out what we had here. Let's comment out the signature. I want you to keep this here as a reference. And we're going to put in one that takes into account the underlying sequence container that supports our stack interface. By default, this is going to be deck, so this is what we're going to pass here. And then we're going to pass this container as a second template parameter. Now that we have this in, we're going to use the same setup to do our clear stack function. Let's go to the next line to have this isolated, and we're going to comment everything out here. We can comment out the function and the template declaration here, and we're going to put in a new one to take into account the underlying container. Now, the moment we do this, we're going to go down and see that our call is going to work even with a different underlying container. This is going to work really well. Now that we have this in, we can even print numbers too. We're going to do that like this. And if we build our program, hopefully it is going to build. And if we have problems, we're going to fix them. But the build is good here. So we can clear and run rooster. And this is going to print our data. If we look around, we're going to see that in numbers 2, we have 5 and 6. 6 is going to come out first. That's what we see here. In numbers 3, we have 7 and 8, and 8 is going to come out first. That's what we see here. And in numbers 4, we have 9 and 10, and 10 is going to come out first because it is the last thing to go in. And this is classic stack objects working in action. This is really all I had to share in this lecture. I hope you found it interesting. The main idea is to expose you to how you can use a stack container adapter in your C++ program. The main design principle for it is that the last thing to go in is going to be the first thing to come out. And use this in your C++ programs if it makes sense for whatever problem you are trying to solve. We are going to stop here in this lecture. In the next one, we're going to learn about the Q container adapter. Go ahead and finish up here and meet me there.